Hi, this is Vijay Kumar from K.S.Rangasamy College of Technology. In this video, we are going to discuss about constitutions of alloys and solid solutions. First of all, we should know what is meant by an alloy. An alloy is nothing but a substance which has a metallic property and it is made up of two or more chemical elements of which at least one should be a metal. So normally an alloy is a substance which has a metallic property. So along with that we can add two or more chemical elements in order to enhance the physical property of the material. So some of the ancient alloying element are brass and bronze. Here the copper is the common metal in both brass and bronze, but the alloying element, that is the chemical element, is differing. In brass it is zinc, in bronze it is tin. So we can easily able to identify which one is the metal and which one is the alloying element. In case of brass, copper is the metal and zinc is the alloying element. In case of bronze, copper is the metal and tin is the alloying element. In recent times, the steel is the one of the major alloy applications which is used in various places. So steel is an alloy element which is made up of different chemical elements and also metals. So major component of the composition of the steel is iron and carbon. Along with that we can add different kind of alloying elements to enhance the property of the steel. So some of the alloying elements are chromium, nickel, manganese, molybdenum, silicon, tungsten, vanadium, etc. So these are some of the alloying elements which is added to the steel. So alloy is made up of metal and some of the chemical elements. So the composition of the metal in the alloying material is about 90%, whereas remaining 10% is occupied by the chemical elements which is added to the metal. So major composition of the alloy is metal. So around 90% of the metal occupies the alloy material. So next we are going to see about the structure of the alloys. So normally the pure metal will appear in a crystalline lattice. So the atoms of the pure metal will arranged in a crystalline lattice manner. So in this diagram we can able to see the pure metal atoms arrangement. That is the even arrangement of the atoms in the crystal lattice. So when we consider the alloy, apart from the atoms of the main metal, there is also atoms of the alloying agents are there, right? So since alloy is a combination of metal and chemical elements, so there is the possibility of atoms of the alloying agents in the crystal lattice, right? That is the structure of the alloy. So these are all some of the atoms which are in blue colors are the alloying agents atoms. So which is occupied in the crystal or structure of that alloy. So if we consider the structure of the alloy, not only the atoms of the main metal is there, but also the atoms of the alloying agents will occupy some of its spaces in the structure of the alloy. In this alloying structure, there are two kinds of alloying structure are there. One is substitution alloy and next one is interstitial alloy. In substitution alloy, the atoms of the alloying agent replaces the atoms of the main metal, right? So in the diagram you can able to see the substitution alloy diagram, in which the pure metal atoms are replaced by the alloying agent, right? So this is the substitutional alloy. So it is possible only if the atom size of the base metal is equal to the atom size of the alloying agent. If the sizes of the both alloying agent and pure metal atoms are same, then only it is possible to substitute the atoms in place of pure metal. Alloying atoms will be able to substitute the places of the pure metal atoms. So next one is interstitial alloy. So in this case, the agent atoms slip in between the main metal atoms. So in the third diagram you can able to see some of the green dots in between the red dots. The red dots represents the pure metal atoms, whereas these green dots represents the atoms of the agents which is added to the main metal, that is pure metal. So it will slip in between the atoms of the main metal, so it is termed as interstitial alloy. In some cases there is also possibility for combination of substitutional and interstitial alloy, in which both the alloying element will able to substitute the pure metal atoms, and also it will able to slip in between the atoms of the pure metal. So there is the possibility for substitutional and interstitial alloy also. Next we are going to see about the alloy behavior. So why alloying is needed to the metal? So the main purpose of the alloying is to enhance the physical properties of the base metal. So if you consider the iron as a base metal, it is used in various building materials. So if we add some of the alloying elements with the iron, namely carbon, it is changed as a steel. So the alloying element of steel is iron plus carbon. So if we add the carbon, the disadvantage of the iron is rusting. So by adding the carbon, we can overcome the rusting demerits in the iron. So the main motto of alloying is to enhance the physical property of the base metal to use in various applications. So finally, how the alloys are made. So what is the process involved in the making of the alloy? So there are two ways of alloy manufacturing. First one is by means of solid solution, and next one is by means of powder metrology. So solid solution is the traditional way of making alloys, where the metals and the chemicals were heated and melted to make the components in forms of liquid, and then we have to mix together and allow them to cool so that it can be form into a solid solution. So by melting the base metal and alloying elements, we can make the liquid phase of the material, and then we are allowing that liquids to form a solid solution. So the next one is the powder metrology, in which the components are the base metal or alloying metal, and alloying metal are made into powders, and we are going to mix together and fuse them into a material by means of high pressure and temperature. So it is the process of powder metrology. So this is some of the basics of constitution of alloys and how solid solutions are formed. Thank you.